At the beginning of the course, when I introduced HTML, I showed you how to embed images into a web page. But I didn't really show you how to embed video and audio streams into the web page. And so I'm going to take a break from talking about server-side programming to go back and talk about how we introduce rich media into web pages using HTML5. So it turns out this is actually fairly difficult. Video is a really complex system. When you create a video file, you're actually creating a container. And that container file holds several tracks of audio and video that are encoded using different codecs. They're almost like mini files inside the container file. And each of those tracks stores a lot of information. And in addition, the container may have information about the tracks, such as track names, or the length of the track, or the length of the entire video file. There's a lot of meta information that gets stored, as well as possibly subtitle information, so that users who want closed captioning can follow along as the video plays. There's also a bunch of information in the container to keep the audio and video tracks in sync with each other. In other words, there's a lot of stuff going on. It's a very complex file format. Part of what makes it complex is that the audio and the video tracks can be encoded using several different codecs. A codec is an algorithm for encoding and decoding the video file, or the audio track. So we need to have codecs because without them, our files would be enormous. To illustrate this, I ran some numbers. So let's suppose, for example, that we had a 10-minute video in 640 by 480 resolution. Now, that's not very good resolution. Most monitors today are at least 1024 by 768, and most of them are much larger than that and have much higher resolution. This is well below 1080p. If I have 10 minutes, that's what, 600 seconds of video at 24 frames per second on a 640 by 480 color video, it's going to take about 12.35 gigabytes of space. So it's going to be a very large file. And that's not even counting the audio. That's just the video track. However, if I were to encode that with one of the modern video codecs, with H.264, I can compress that data down to about 50 megabytes of space. So this is an enormous savings, from 12 gigabytes to only 50 megabytes of space. Another way to think about that, if I were to download that uncompressed video on a 100 megabit Ethernet connection, it would take me almost 18 minutes to download the whole thing. But if I compress it with H.264, even including sound, it only takes about 50 megabytes. And so I can download the entire video in about 4 seconds. So it makes an enormous difference. But unfortunately, there are lots of different codecs. There are lots of different container formats. Some of the important container formats are here. So one video container is called an FLV file. FLV stands for Flash Video. It's Adobe's container format that's used with the Flash plugin. So if you pull up a video in a web browser, especially on an old browser, old versions of Firefox, old versions of Internet Explorer, old versions of Chrome, old versions of Opera, probably it's not going to play video directly in the browser. Instead, it's going to load some external plugin like the Flash plugin to render that video. And Flash files usually use the FLV format. FLV doesn't give very good compression or video quality, but it's better than an uncompressed video. Another container format is the AVI format. It's a format developed by Microsoft. It stands for Audio Video Interleave Format. It's one of the most common formats out there. In fact, it's still widely used on the web, but it's not supported on most modern mobile devices, including the iPhone. You can actually play AVI files on the iPhone, but to do it, you have to install the Linux video player. There's a port of the Linux video player VLC to iPhone. And if you install that, you can watch AVI files. But as a web developer, you should not assume that your users have done that. It's a fairly complex process, and so most people who use an iPhone won't be able to see your video. It produces fairly large files that are slow to download by modern standards, but 10 years ago, it was state-of-the-art. Microsoft replaced AVI with another format called ASF. This hasn't been nearly as widely used, but if you've ever downloaded a .wmv file and played it in the Windows Media Player, it's using ASF container format. ASF is not widely supported outside of the Microsoft world. If you want to play it on a Mac or in Linux, for instance, it might work, might not, probably not. Another container format is called 3GP. This was the format used on certain old cell phones. So if you had a third generation mobile phone, a 3G phone, it might have used this format. I think it's based on AVI with some slight differences, but it's out there and it's available. Here are some more modern container formats. So probably the most popular format right now is the MP4 format. It was a standard. It's standardized by the Moving Pictures Expert Group, the MPEG group. It's not royalty-free. What does that mean? It means that for most uses of MP4, non-commercial uses, if you want to post pictures of your cat playing in the backyard, you can just use MP4 and not worry about it. But if you're trying to use MP4 to make money, if you're selling sports videos, or if you're streaming some event live and charging some subscription fee, some of that money that you collect has to go back to the MPEG group. They charge royalties for the use of the MP4 format. So a lot of people ignore that, but they're doing that at their own peril because they could be sued. One of the more popular formats, MP4 is widely supported by browsers, including Internet Explorer 9 and Safari and Flash, and I think Microsoft's Edge browser. It supports almost every audio and video codec. It has a lot of advantages, but people worry about it because it's not royalty-free. And so a bunch of open source developers got together and they developed a codec that would be royalty-free to compete with MP4, and they called it OGG, O-G-G. The OGG format is a free and open source codec. It doesn't get as good compression as MP4 most of the time, but it's supported in Firefox, in Chrome, and Opera. It's actually losing popularity because there's a new format that's become popular that Google's been pushing really hard called WebM. And WebM is based on a format called MKV or Matroska. It's a royalty-free open source codec. I'm sorry, not a codec, but a container format that was developed by Google. It's supported in Firefox, Chrome, Opera, and on Android mobile. Notice what's missing here again, the iPhone. Some iPhones, I think, now have some limited support for WebM. At any rate, it supports the most popular codecs and has better compression than MP4. You get much better quality videos with WebM. We'll talk about how to handle it on iPhone in a minute. So once you've chosen a container format, you still need to choose the codecs for video and for audio so that you know how to put them all together. And there are a bunch of different choices for the video codec. There are actually probably several hundred of them, but I've listed, I think, 5 of them here. Probably the most popular format 10 years ago was MPEG-4 Part 2, which is also called MPEG or sometimes called DivX. They're basically the same thing. It's an older format. It was the format that was used by DVDs. Before Blu-ray. So if you bought a DVD, the video on it was encoded using MPEG-4 Part 2. Again, MPEG is the Moving Pictures Expert Group. It's also pretty commonly used for web video. So if you look at old web videos on, not on YouTube, because YouTube's moved to WebM and to a different encoding, but a lot of the old video sites, you'll see MPEG-4 Part 2 videos, DivX and MPEG. This is especially true in Windows. Microsoft created a proprietary codec that they called Windows Media Video Format. It was used with ASF containers primarily. It has better compression than DivX, but it's not widely used anymore. Instead, Microsoft, like most of the rest of the video world, has moved to a codec called 264. It's sometimes called X264. It's sometimes called H264. It's also sometimes just called MPEG-4, although that's really the description of the container format that it's used with, because it's usually used with MP4 containers. It provides several different kind of profiles or levels of compression. So if you want really high quality video and you don't care if your file is a little larger, you use the high profile. The high profile gives you the best quality, but it doesn't necessarily give you the best compression. If you care more about compression and less about video quality, you can use the baseline profile. The baseline profile is great for like mobile devices because it shrinks the file way down so it downloads fast. But in order to do that, it has to sacrifice some video quality because it's a lossy compression. X264 is used by Blu-ray. Blu-ray actually supports 3 different video codecs, and this is one of them. It's also used by many streaming video services. Another alternative codec is Theora. This is what's used typically with OGG containers. So you'll see OGG Theora video files, or sometimes, OGT files. It's an open source, lossy compression format. Again, it's losing ground now because Google has released a new codec called called VP8 that goes with WebM that's replacing OGG pretty much everywhere. VP8 is the one Google's pushing really hard. It's usually used with WebM containers. It gives you very high compression and good video quality. So it's a really impressive codec. It's very widely supported, except again on the iPhone. Depending on what version of the iPhone your customers have, they may or may not be able to play VP8 WebM videos. You also have a lot of choices for an audio codec, and you can use any of these codecs with any of the video codecs in any of the container formats, so you see why this gets so complicated. Probably the most straightforward audio codec is uncompressed audio, and uncompressed audio is sometimes called PCM audio. That stands for pulse code modulation. It's also sometimes called a WAV file. WAV files and PCM files are slightly different, but close enough for our purposes. Basically what you do is you sample the sound 48,000 times a second or something like that, and you record the volume in a file, and then when you play it back, you just make the speaker change volumes that quickly, and you get audio. WAV files take up a lot of space because they're not compressed, so 10 years ago, the most popular format for storing audio was an MP3 file, and I'm sure you've heard of MP3s because they're everywhere. MP3 is still really commonly used as the audio encoding for video files. In fact, a lot of MP4s have MP3 audio. A lot of WebM containers use MP3 audio. MP3 is short for the MPEG-2 Audio Layer 3 codec, and it's often used for just standalone audio files. If you want to download an audio book or some music, then you probably download as an MP3. Unfortunately, MP3 uses lossy compression. That means that it's actually throwing away some of the audio information. Now, the idea behind MP3 was to throw away audio information that didn't matter. And so the MP3 algorithm tries to throw away pitches that are beyond the range of human hearing, or pitches that are below the range of human hearing, or things that are so quiet that you can't hear them anyway. But sometimes it's unable to do that. Sometimes in order to shrink the file down into a reasonable size, it has to throw away audio information that does alter the sound. Also, a lot of people who are audiophiles claim that they can really tell the difference between an MP3 encoded audio file and, say, a CD. So it does lose some audio information, but it creates very reasonably sized files, much smaller files than, say, a WAV. An alternative to MP3 is the AC3 format. This is also called the Dolby Digital format. It's used on DVDs sometimes, but it's also used on Blu-ray. An alternative that's free and open source and royalty-free is the Vorbis format. It's usually used with OGG files, but it can also be used with WebM. It has fairly good compression. Like MP3, it's lossy, but a lot of people claim that it loses less audio information. You get better quality audio with OGG Vorbis than with MP3. So especially at low bit rates, some people claim it sounds even better than AAC, which is Apple's alternative encoding. Apple came up with a codec called AAC, which stands for Apple's Advanced, It stands for Advanced Audio Codec. And it's used by iTunes and in MP4 videos. It's got pretty good compression and quality. It does use lossy compression, but supposedly, again, the audio quality is still very high. It is patent encumbered because Apple likes to make money off of their products. So that was a lot of information. And the short summary, the too long didn't read, is basically this, 3 points. Number one, on really old browsers, the only way to play video is to use Flash. So when you're designing a web page that provides video, you should provide a video format that's compatible with Flash. Typically, that means you should use an MP4 container, and that MP4 container should have video encoded using H.264 baseline video with an AAC audio track. On old mobile devices, you don't have support for MP4, so instead you should use a 3GP file that contains H.264 baseline with AAC. On newer mobile devices and on the desktop, so most modern computer web browsers, you should use WebM with VP8 encoding and Vorbis audio. Or you can use MP4 with a high-profile H.264 video. So if you want to maximize playability, you should provide at least 2 versions of every video, an MP4 file and a WebM file, and the MP4 file should be encoded using baseline profile with Apple's Advanced Audio Codec. And that'll maximize compatibility and the quality of your encoding. So we figured out what container format we want to use. We figured out what kind of video codec and audio codec we want to use. We've generated our video. Now, how do I put it up on the web page? Well, before HTML5, this was really hard. It turns out that the original HTML standard didn't provide any support for video. In fact, web browsers didn't have a way to play video. Video was considered very hard. Writing a video player was a difficult thing because you had to support all these different codecs and decode them, and that was very computationally intensive, and so you had to write really good code that would be very fast, and it wasn't considered an easy task. So instead, most browsers would sort of delegate the task of playing video to some external program. They didn't want to have to write the code for video and make the web browser a really complex piece of software, so they would say, okay, we're going to call this other program that already plays video, and we're going to plug it into the browser. So one of the most common plugins for playing video was the Adobe Flash plugin. There were others, but Flash kind of ruled the world for a little while on the web. And if you wanted to summon some plugin to play video, you had two choices. You could either use the embed tag or you could use the object tag. The embed tag was supported by many browsers, although it turns out not all. And it opens a URL in an external plugin, like Flash Player. But it was never incorporated into the HTML standard. It was never an official HTML tag. Browsers supported it, but it wasn't part of the standard. And so if you tried to validate your page and you had embed tags, it wouldn't validate because you were using this non-standard tag. Part of the problem is that which attributes it took depended on whether it was calling the Flash plugin or some other video player. And so it wasn't standardized. You couldn't say, I'm going to use this attribute. You had to say, well, if it's this, use this attribute, but if it's that, use that. So you'd wind up with a bunch of embed tags. It was a big mess. So to try to fix this, the HTML working group, the World Wide Web Consortium, they actually did add a tag to HTML for pulling in embedded video. And it was called the object tag. And so you would say object, and then you would say class ID equals in this big long string that I have here, CLS ID colon, and this big long hexadecimal number. We'll come back to what that is in just a second. But the idea behind the object tag was to provide a standardized way to embed video. Unfortunately, Microsoft is the one who developed this object tag, and they really designed it around their browser. And so this class ID attribute is actually a Windows registry key. It basically says, pull up the program that this registry key points to, which would happen to be Flash, and play this video. So it wasn't supported by all browsers. Certain versions of Opera, for example, didn't support the object tag initially. It relied on having an external plugin. And to configure it, you would add these param tags. Param stands for parameter. Excuse me. That was very difficult to use. Object is actually still around, but it was heavily revised in HTML5. You can still pull in files using an external viewer using object. That's primarily now used as a fallback. If the other ways of playing video fail, you can still load the Flash plugin to play video. Neither embed nor object worked well in all browsers. So what wound up happening is that in a lot of web pages, the developer would use both. He'd actually create an object tag and a slash object tag, and in between he'd put a bunch of embed tags. It was a mess. So HTML5 solves this by adding video and source tags. And the video tag is really straightforward. It's pretty simple. You just say tag video, and then you can specify some attributes. And then inside, between your video and slash video tags, you can specify one or more video sources. And you do that with the source tag. And the source tag takes an SRC attribute that contains the file name. And the advantage of this is that I can say, OK, if this video type is supported, use it. But if it's not, here's a fallback. And so I can have the same video recorded in MP4 format, in WebM format. I can have it recorded with several different video codecs. And then I can put in these source tags that say, OK, here are some options. Play the first one you find. That's really nice. And then, if it doesn't find any of those, I can embed some HTML into my video tag that will be displayed if the video couldn't be played. So here I can say, for example, in bold tags, video is unsupported. And that will only show up if it wasn't able to play the MP4 and it wasn't able to play the WebM file. Another big change is that in HTML5, video is handled by the web browser itself, not by a plugin. So the video file actually becomes an object in the DOM. And that has a lot of advantages, as we'll see in a minute. One of the advantages is that I can now manipulate it using JavaScript. So I can use JavaScript to pause or play a video, or change the volume and do other kinds of things. Unfortunately, the video tag only supports 3 of the video container formats. It supports WebM, MP4, and OGG. So those are your only choices with HTML5 video tags. If you want to have some other format like a 3GP, you're going to have to go back to using the object tag or the embed tag to try to pull in an external player. It does allow multiple video sources, as I said before, in case the browser doesn't support a particular format or codec. And it allows us to provide some code to be displayed if none of the sources can be used. So the video tag actually provides several different attributes that we can use. One of them is the autoplay tag. It's a Boolean tag. You can just say angle bracket video autoplay and then close your angle bracket. And what autoplay does is it causes the video to start playing as soon as it's fully loaded. So modern web designers recommend not to use this tag. It's considered a bad idea because it annoys users. Users like to feel in control of the web page, and they don't like it when things start playing automatically when they load the page. So it's up to you. Use your discretion whether you use autoplay or not. There may be some circumstances in which it's appropriate, but the recommendation typically is not to use the autoplay attribute. Another Boolean attribute is the controls attribute. If you leave out controls, you'll get a little window that shows you the video, but you won't have a way to play it or to pause it or do anything with it. If you add the controls Boolean attribute, if you say video controls, angle bracket, then when the video loads, it'll display a play and a pause button underneath it the user can use to start and stop the video. You can specify the height and the width of the viewing screen. You can also use the loop Boolean attribute to cause the video to repeat over and over until the user clicks stop. Another nice attribute is the poster attribute. It's not a Boolean attribute, it's actually a string. You can say poster equal sign, and then in double quotes or something, give it a file name. And it'll load an image from that file and display that until the user plays the video. So you can put kind of a nice little teaser picture there, maybe a corporate logo or something like that. Just as HTML5 provides a video tag, it provides an audio tag. It's very similar, except it's for playing audio files instead of video. Like the video tag, it takes attributes, and one of those is the controls attribute. So here I've said, embed an audio file, show the controls, and here are 2 sources that you can retrieve the audio file from. And again, it'll try the MP3 file first, and then if it can't find that, it'll try the WAV file. It only supports MP3, OGG, and WAV formats. If you want to use something else, like an AAC file, well, then you either have to convert it to one of these 3 formats or use something else. It does support autoplay, controls, and loop attributes, just like the video tag does, and they behave the same way they do for video. HTML5 also redefined the object tag. So we still have the object tag, but it behaves differently. You don't have to put the class ID attribute in anymore. But you can use it to load in files into an external plugin like Flash Player. It does take a data attribute still. The data attribute is how you specify the file name to load. And like video and audio, if you put some text or some HTML between the object and the slash object tag, that text will be displayed if the file can't be loaded and played for some reason. Maybe the proper plugin isn't installed. You can also embed the object tag inside a video or an audio tag. And so if you do that, then it'll try to load the other video sources first. And then if those fail, it'll try to use Flash or whatever the appropriate plugin is to play your object. So this is a way to have Flash be a fallback if your standard video formats don't work. So I mentioned that one of the advantages of making video and audio first-class objects in HTML5 is that we can manipulate them using JavaScript. So here's a little example. Suppose that I create a video object and I give it a width of 640 and a height of 480. I'm going to set its ID to movie, and that's going to be important later. And I'm only going to have one source tag. It's an MP4 file named movie.mp4. Notice I specify the type. It's video/mp4. And if that particular browser doesn't support MP4, it'll print out video not supported. Beneath my video element, I'm going to have 2 divs. And one will contain the word play. The other will contain the word pause. I'm going to use some CSS to style them. Basically, I'm going to create a play and a pause button. When they click on the play div, it's going to call a JavaScript function named start video. When they click on the pause div, it's going to call a JavaScript function named pause video. And those functions are here in green. The start video function just uses getElementById to fetch the movie object. So this is just the same function we've been using the whole time from the DOM, the document object model. It searches for a div or an HTML tag named movie. So here it's going to get our video element named with the ID movie. And it's going to put it into a variable named movie. And then to start the video playing, I just say movie.play. It's that easy. Similarly, to pause the video, I use the DOM to get the video object, the movie object, and then I say movie.pause, and it'll pause. So this is what that'll look like. Here's my video element at the top. This is one of the lectures from a couple weeks ago that I've embedded in here. And notice I've got my divs below, my play and pause button. When I click play, the video will start playing. When I click pause, it'll stop. I can also use JavaScript to adjust the volume. So I could maybe add a couple more divs, a couple more buttons for changing the volume up and down. So here's a volume up function. I use the DOM again to get the movie object. And then I say movie.volume equals movie.volume plus 0.10. What's going on here? Well, the volume is stored as a variable inside the movie object. It's a property of the movie. And so if I want to raise the volume, I just add to that variable. And if I want to lower the volume, I just subtract from that variable. So here in my volume down function, again, I fetch the movie object, and then I set the volume to be the volume minus 0.1. The volume is a number between 0 and 1. One of the neat things is if you try to make it bigger, like if you try setting it to 2, JavaScript will automatically round it back down to 1 for you. So that's kind of neat. And if you try to set it to a negative, it'll automatically round it back up to 0. So it will keep track of that for you and make sure it's always between 0 and 1. So you can think of this as I'm adding 10% to the volume each time we change the volume up, and I'm subtracting 10% each time we set the volume down. You can also mute and unmute the video. To mute it, you just set movie.muted to true. And to unmute, you set movie.muted to false. So I've got functions for that. Muting doesn't change the volume. It just makes the movie silent temporarily. If you mute and then unmute, it'll play at the same volume that it was at before you muted. So that's a really neat implementation. You can implement rewind and fast forward just by doing something similar to what we did with volume. Instead of changing the volume, we change a variable called playback rate. So again, to rewind, I get the movie object from the web page using the DOM. And then I set movie.playback rate. Notice the capital R here, no spaces, no underscores, just playback rate with a capital R. And I'm going to set it equal to -1. So negative numbers will make it move backward, make it rewind, and positive numbers will make it move forward. If I want it to go fast forward, I can double the playback rate by setting the playback rate to 2, and it'll go forward twice as fast. And if I want it to be at normal speed, I just set the playback rate to 1, and it'll go 24 frames a second, or whatever the default speed of the movie is. Unfortunately, playback rate is not supported well in all web browsers, so this may or may not work depending on what browser they're using. However, most web browsers do have good support for something else, and that's advancing to a new place in the movie. So for example, if I want to go forward 10 seconds in the movie, all I have to do is update the current time variable. So I can say movie.currenttime equals movie.currenttime plus 10, and that will advance 10 seconds in the movie. So current time is expressed in seconds. If I want to jump a minute ahead, I just add 60 seconds, and that would jump me ahead a minute. Similarly, to go back, I just subtract a certain number of seconds. So here I'm subtracting 10 seconds. So in summary, video and audio can be embedded in HTML5 pages using the appropriate tags. You can specify media files to use as sources for video and audio with the source tag. And then you can use JavaScript to implement your own media controls, so it's very flexible and powerful. If you want to maximize the number of browsers that can actually see your videos, the number of users that can actually watch them, you have to provide at least 2 video files. One should be an MP4 file, and one should be a WebM file. And then you should use an object tag to create a fallback for Flash players so that really old web browsers can view it in Flash. Have a great week.